So I was just going to integrate square root of x, raise the power, divide by the new power divided by 3 over 2 is multiplying by 2 over 3, plus c over and up. This one is a little more complicated. Okay, so we're going to do this thing called U-Substitution, and I'm going to make this look just like that, or as close to that as possible. The thing under the square root, I want it to be simple, so I'm going to say 4x minus 1, your name is now u. And I'm going to do the derivative of u with respect to u on this side, the derivative of x with respect to x on that side. So technically, the way we would have written it previously is du dx equals 4. I'm just moving the dx to the other side. So x's are all over there, and u values are all on the left. All right, so now let's translate. Alessandra, instead of the square root of 4x minus 1, it's going to be the square root of, what is 4x minus u? So square root of u. I need to translate everything though. So Ellie, I want just dx. I need to do something. What is dx by itself equal to?
Du over 4.
Yep, du over 4. So I'm going to get rid of the dx. And I can put that over 4 anywhere. Cleo, what's your preference? Do you want the 1/4 out front of the curly Q or out front? Okay, just quickly out front. Okay. It could go under the thing inside, doesn't matter. That was Cleo's choice, so we put it outside. And now I'm going to do the same problem I did over here, but I'm integrating with u. So u to the half, raise the power, divide by the power, so dividing by 3/2 is multiplying by 2/3. That 1/4 is still there, plus c. Okay, there's one last step. I actually wanted everything in terms of x. So Kai, I need to swap out u and put the x values back in. What was u equal to in this case?
4x minus 1.
4x minus 1. And I'm going to reduce. There you go. Integrate. And some of you are able to do this without U-Substitution because we ended up like raise the power, divide by new power, and then chain rule, divide by the derivative of the stuff inside. Just dividing by a 4, cool, no problem. When it's just a number, that's all right. However, the next example, not okay. Even if you can do this, don't. I won't give you credit for it. There are options with this one. So things that you're going to choose to be that u value. It's the thing in the denominator. It's the thing under the square root. It's the thing that is the variables in the exponent. Or maybe it's the thing being raised to an exponent. I got choices here. Another hint is you might see the derivative of one piece somewhere else in the problem. That other thing that you see its derivative, that's the thing that would be u. Anybody have a guess what a good choice would be that would be? Jared?
X squared.
X squared?
No. X squared be x to the square.
The whole thing? Okay, if we were to do that, all right, getting du, I'd have to do chain rule and product rule, and I'd get a couple lumps. That looks really hard. I'd rather not choose that one. But Jared, sometimes that craziness works, like the bigger complicated thing.
X to the third.
x to the third. Okay, if we try that, the derivative of x to the third is 3x squared. So, and right now, I see x squared dx here and x squared dx there. That's looking promising. I'm liking this. Okay, so Adam, I want to swap things out. I want to get rid of all the x's and put in u values. What does that become? E to the u. So now, oh, and what's left? I have an x squared and a dx. Solve for x squared dx over here.
du of 3.
So this junk x squared dx, I'm going to swap out and put in what Owen just said. Du, I'm going to call it the Cleo rule. I'm going to pull that 1/3 out. The 3 can be underneath, inside, but it's just ugly and in the way. We're going to push it out. So Sam, looking at just this stuff inside the integral. Integral of e to the u with respect to u is just e to the u. So it became so much easier, right? What do I do with the 1/3?
Just keep it.
Keep it. And that I had no numbers on there. Ethan, what do I need to remember to do? There's no numbers, it's indefinite, so
Plus C.
Lexi, I don't want it with u values in it. I gotta swap it back out again. What is it?
1/3 e to the x cubed plus e.
Yes. Okay. But I said there were options. The heart surgeon sees things differently. That student was like, I see this. I want it to be e to the x cubed. Okay, e to the x cubed is e to the x cubed times the derivative of the exponent. Wrong thing. Because he said, I see all of these things there. He said, I'm going to integrate du all by itself. The integral of 1 du is just u plus c. But plugging his u value in, same answer. I do not see his way as straightforward, but I am also not a heart surgeon, so. All right, okay. Let's try another one. Colin, you suggestion?
X plus 2. Du.
U
It's gonna be
equals
1.
1 in the x. Okay. X plus 2, that becomes u squared. Dx is du. Raise the power, divide by the new power. and add C, but I didn't actually want U values. And yes, it is that simple. You were given a problem like this in the past on something else, and you didn't, I suggested that you guys do this by integrating the expansion, raise the power, divide by the new power, raise the power, divide by the new power, plus C. They look super, super, super different. Okay. Well, using my triangle, coefficients of this thing expanded, 1x cubed plus 3x squared times 2 plus 3x2 squared plus 8 all over 3, x cubed over 3, 2x squared, the 3's reduced, these 3's reduced also, 4x, and then I get 8/3 plus c versus just plus c. They're not exactly the same. Is that a problem? Gabriel's saying no, why not?
Because C includes all values, so you don't need the 8/3.
So this c is a different value than that plus c. They're both unknown lumps, so this lump is a little 8/3 smaller than that lump up there. They are still exactly the same. They look really, really, really different. But that's fine. They're both correct. All right. Here's the real check. Okay, here's where the thinking part is, like, what the heck is the U value on this one? Sine is cosine's derivative, cosine is sine's derivative. Okay, one of them's got a negative floating around in there, but that counts as a constant to me. One of them's being raised to a power. And yes. Yeah, oh, Arabella, what do you think?
Can we just split it out into two different tables or what?
No, we can't. Multiplied things we can. If it's added or subtracted, we can, but multiplied, no. Good idea, but it's not. Yeah.
I think U should be sine x,
Why is that your instinct?
because sine x, because then you can do U to the fourth. Oh, and the derivative, du is cosine.
Okay, Gabriel, what were you gonna say?
I was gonna say cosine.
Okay, so let's. Boom. Someone else immediately just vetoed that. No. All right, so let's see. If we were to translate this with the U value being cosine, that's gone. Then, negative sine dx, like now I've got lots of problems because I can't have du to the fourth, that's not gonna work. And it'll show up pretty quickly if you had chosen poorly what your U value should be. But let's make sure, I mean, maybe they both don't work well. Instead of sine to the fourth, it's U to the fourth. What does cosine dx swap out there? Becomes just du. So is this plain and simple power rule? Amelia, what's that gonna be? How do I,
U to the fifth over C.
The power rule, raise the power, divide by the power, and then go, oh wait, wasn't actually integrating U values. And then swap the x's back in. What do you think? Scary monsters? Well, we need to translate everything. So the question was, why do we take the derivative of U? Well, if I'm changing this into U values, I need, like, I found the height in terms of U, I need to find the width in terms of U as well. I need to do areas of my rectangles all with U values. I can't say, well, like the car velocity, we found miles per second squared minutes. We did crazy things and we had to make them all the same units. So I can't integrate U values with a dx. I can only integrate U values with du. So I needed to create a du. Because your miles per hour is very different than the number as kilometers per hour. It might be the same value, but the numbers are different. Okay. This is technically day 2 of U-Substitution. Oh my goodness. This is where we got to in the last class as well, so. And I apologize, 2 letters are gonna come up soon enough. So why do they choose U's and V's? Because some of you write your U and your V is exactly the same. I don't know why. Your U's and V's look the same. Okay, so when we get to integration by parts, which isn't yet, by all means use A and B, use 2 letters, I don't care what. But make them distinguishable. Ellie, suggestion on what to choose as a U value for this? Probably the thing in the denominator. Good idea. So Kai, what is du?
3. Yeah.
3,
Yeah.
not 3, yes, 3 dx. Okay. Gonna do the Clio rule again, stick the 5 outside because it's just clouding things in here. 1 over u and dx equals 1 over 3 du. 1 over u, how does that integrate? ln, jail bars. ln of the u value. I already swapped the x values in. I didn't even think about it. Sorry about that. There it is. Okay. So this is as far as I got in the last class. So do you guys have questions about the test? Yes? No? Yeah. Okay. Pick a number. Okay, guys, I did a few of these in class. The number of the 90-something students that got this right is less than 30%, and if you did not get this right, it was an immediate -2. I did not look through all the messy, wrong math that you wrote down. It was just like, -2, what the heck, man? What does this shape look like? A semicircle? Which part? Top, bottom, left, right? It's the top part. And I'm asking you to integrate from 0 to 10. So I only want 1/4 of it. What's the radius of that circle going to be? 10. So this is gonna be 10 squared pi divided by 4. So whatever version you had to find, the test had some number plus a semicircle. And I asked you for a quarter of the circle plus a rectangle. You got a point for finding the area of the rectangle. A lot of you got the 12 or the 18 or whatever it was. And then did not get the circle correctly. Okay, so I thought I did that. I thought that would be an easy one, and I was clearly wrong. Were there any other issues on the test that you guys wanted? Units in context of the problem. I didn't necessarily take points off, but I put comments on there. Some of you said things like over the 8 minutes. Yes, and AP might sometimes give you 1 hour of data and say, this is the 8-minute period, so you have to say over minute T0 to T8. I know what you meant by the 8 minutes, and that is the whole interval they gave you, but they very specifically want stuff. So what 8 minutes? This 8 minutes. And someone just said temperature. Last year, people just said gallons, and they didn't say gas, so they didn't get the point. So you might have to say temperature of the coffee. And don't tell me that the coffee increased its temperature by sitting out and cooling off. It was supposed to decrease. Did you have a question in particular? No? Any other specifics on the test? Most of you did well on the front page. Okay.